Welcome to Level C Math, Week 6, Thursday. So we finally get to finish up the mad science topic today. We've been pausing throughout measurement for quite a while. Last week, we paused because we had these 4 handouts to try and do, and they worked pretty well. We proved that, yes, we were caught up. We could do all the stuff that any other level C class was doing on Moodle, even though we weren't using Moodle. We were learning the same things. And then we had a big review day last time. So we talked about unit analysis and polygons and perimeter and area and circles, almost as if we hadn't before. I went faster, and we didn't have quite as many example problems as when we saw those things the first time, but hopefully anyone that was feeling shaky or missed it the first time is feeling more caught up. So we're almost done. Prisms had surface area and volume, and we talked about surface area, the edges of a cardboard box, the fabric around a tent, and how you could think of it as either cutting the sides apart or possibly, as in this brown picture, unfolding it, and then just add up all those flat areas. There was a challenge if you wanted to see which of these colorful folded shapes, if you did cut them out and fold them up, would actually make this triangular prism in the middle, or which would not do that. I haven't tried it myself. I don't know what the answer is. Did anyone work on that at home?
I didn't get a chance.
We'll see how bored or excited I feel this weekend. Maybe I will or not. Right now, there's no answer in the answer key. So someday I need to try that to make an answer key. Okay, so the last thing to talk about is volumes. And for volumes, I will start the Jamboard. One moment, let me check off that someone is here for attendance. Oh, okay. On our Jamboard, I have reminders on the first page. We'll get to that in just a moment. This was something that I can get rid of because it was for my thing. So we are looking at, hey, did anyone ever play with these wooden or plastic cubes called base 10 blocks?
Yeah.
The math department at LCC has a whole tub of them. We could actually, if we were in person, play around with them. But for now, you just have to see a picture. So okay, so the point I was wanting to make with this picture isn't about base 10 blocks, but that you can think of rectangular prisms. So prisms where all the sides are rectangles, including squares, because square is just a special case of a rectangle, as a skyscraper with multiple stories. So I can say that there is a flat base that's going to be 10 by 10. And maybe my artwork will be good enough to pull this off. Let's see. So there's the 2 edges we can see. And then at the back, and those go up 1 block only. So something like that. So I'm trying to outline just the lowest level of that block, if that makes sense. And actually, maybe I can even just search online. Can I find wooden square flat? Does that give me anything? Oh, it does. Oh, okay. That's better than my lousy artwork. Okay. So what I was trying to point out was that these have flat layers, and you could stack 10 of them on top of each other, because if you erase all of my silly stuff, then we could actually count the sides better. So look, if we tried to count up how many stories tall this is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 of these. It's a 10-story building. It's 10 tall of these flat things. So what volume is asking is, I want some measure of how much space this should take up. And just like if we're finding surface area, then we want to shade in one block that's an inch on the side, or a foot on a side, or a meter on a side, a square, whatever. Then if we're finding volume, we want to find one cube that's an inch or a meter or a foot or whatever on each of its sides. So how many little cubes go in there? So if each story of the building has 10 by 10, that's going to mean that there's 100 cubes here. But we're kind of pretending they're also just flat squares, even though they have height. And then once I reassemble all of those and put them into my skyscraper, then how many little cubes would I have?
Would it be 1,000?
Yeah, and how did you know that?
Is it times the 100 from each square to the 10?
Mhm.
I don't know how I explain it. Sorry.
That's fine. I wouldn't say to the 10 because that means exponent, but we take the 100, that's one thing. And here's our 100. That's like the bottom story. And then we have 10 of those. So it's 10 of those 100. As a formula, all we did was we said that we look at our shape, we try and draw the bottom footprint of the building. So that's going to be length times width. And then when we're done, we also multiply by the height. Well, that was a terrible line. For how tall it is, how many of those stories we have. So volume equals length times width times height. And at level C, that's all we care about. If we were doing more advanced math, we might say, well, what about a shape like this rectangular prism or the tent? How would we find the volume there? In that case, the bottom of the object wouldn't be a length times width, it would be a triangle, a 1/2 base times height. So we'd say something like, for the triangular prism, the volume is 1/2 times base, base times height, where base is here and height is here. And then we'd have some other dimension, which also I kind of want to name height, which is one reason it's confusing. So maybe I'll say tall or something like that, right? But we're not doing that. So let me undo all of that. So to find whatever the footprint of your building is, whatever the surface area of one story of the building is, and then just multiply that by how many stories tall you have. So here is a famous skyscraper named 432 Park Avenue. And it has a ground floor with a certain amount of square feet of area. And then we're wondering what is the actual volume of it. So I'm talking way more than this deserves. All we're doing is the length times width and then times the height. How do I plug things in this time? Space that out a little while you're thinking. Nobody told me the length and the width individually.
Would you be dividing by any chance? You find it or no?
I could try and find the length and width, but I actually don't need to.
Oh, okay.
Remember that all we're trying to do is find the ground floor and then multiply by how many stories tall we have.
I have no idea.
Yeah, I'll give you a hint. I'll draw that there.
Would it be the 412,637?
Yeah, it tells us the length times width already, not separately.
Oh,
That's
good.
And then we multiply by the other number.
I didn't even see that up there.
Okay, well, that's an eyesight check and me arranging it bad. Okay, so I don't know what this is. 1, 4, 1, 2, 6, 3, 6 times 1, 3, 9, 6. So I'm getting 576, 0, 3, 9, 8, 5, 6 square feet. Whoops, it's not square feet. When we were finding area, surface area, or flat area, we were finding square feet or inches, but now we're finding cubic feet or inches, because what we're counting is how many cubics, how many cubes it takes.
She's doing the skeleton dance.
Okay, let's do one more. We have a box up above. There's our box. And it was 2, 2.5, and 4, all of them in meters. So 2 meters, 2.5 meters high, and 4 meters deep. So what's the volume of that box? They start with length times width. And then I multiply by one more thing.
20. Meters.
So the 4 and the 2, the length and the width, doesn't matter which one you call length or width, and then the other one. So whatever that is, 4 times 2 times 2.5, 20, which is what someone called out, right? So cubic meters. And might just write it all out. If you wanted to, you could write this a little differently. You could say 4, and if you put the meters in, then it might make more sense to use the other notation where the numbers all multiply to 20, and then m times m times m is meters cubed. So you might see on a test someday this notation, which just means cubic meters. And you could do the same with inches or feet or whatever, cubic. Okay, and that's the end of everything we do with prisms. The only way to make this harder is to give you more than one prism in a tower. Maybe there would be something on a test someday where there's a whole stack of blocks and you have to do length times width times height for all of them and add them all up when you're done. There's a fun little game if you want where you're trying to make something like that. So. Okay, questions on the 10 exercises for mad science measurement before I think we're done.
I don't have any.
I'm still working on mine.
Okay,
Circles.
did we do all of number 10 before?
I don't know.
I think so.
I believe we did.
Let's do this one because it's a good one. Since prisms were a new topic, I think it is true that if you look at these random exercises, there's nothing about prisms there. And so if you go to the test for mad science, there's nothing for prisms here. I'll see if I can write up something for both surface area and volume of prisms over the weekend. So circle A has a radius of 22 inches. Oh, that's a terrible circle. That's also terrible, but we'll just say okay. Circle B has a diameter of 52 inches. So which one has a bigger area and by how much? I think we need to find two areas. Where would we start?
The first one?
Okay. Anyone happen to remember the area of a circle formula? You don't have to remember it, but
I believe it's pi times R2 or R times R.
yep, R times R, which you would say R squared. So pi times R. I'll write that for both of them. I'm actually going to go open our Desmos calculator so that I have that ready for pi. Okay, so the blue one, I can just plug things in. Pi is on my calculator. 22 times 22. If these are pizzas, they're pretty big. So pi times 22 times 22 gives me 1,521 about. Okay, I can't go quite as fast on my green one. I don't have a radius.
Do you divide by 2?
Yeah,
Radius?
so just from the middle to the edge is going to be half. So half of 50 is 25 and another one makes 26. So pi times 26 times 26. So it's about 2,124. So we're not quite done. By how much? So how much is one thing bigger than another? That's subtraction.
Subtraction.
So 21, 24,
103.
603. Okay. The moral of this story is that as you make a circle bigger, the area increases pretty quickly, right? We're only 4 inches bigger of radius from 24 to 26. The tape measure goes only a little bit farther out compared to before. But we get a whole bunch more area. It's almost half of what we had, right? 1,200 would be double this. So. Is that enough circle review?
Yeah.
I was stuck on the one that had a rectangle with a half circle at the end.
Rectangle with the half circle. There was one that was a picture. Is there?
I did not understand what was happening on Tuesday with that one.
Oh, okay, well, let me just go back then to Tuesday's thing. That was an example problem, so it's not going to randomly make new numbers for me. Did we do that on this Tuesday or was that?
Yeah, it was this Tuesday.
That one? Are you wanting me to talk about the perimeter or the area?
How you got the numbers for the half circle?
How I got the numbers. Okay, so this side is 2.9.
Mhm.
So that means this line is 2.9. So that's our diameter. It goes all the way across the circle, right through the middle. Then we said the radius is going to be half that. Starting at the middle is half of that diameter. Just like in this one, the diameter was 52. So we said half of that will be the radius.
Okay, I think I'll have to go back and watch that one.
Oh, okay. I can draw it without all the clutter on it. So no, it's not letting me copy and paste to that. One moment then. I'll have to go back to where it is in the lecture. Okay, so we said that this is 2.9. So that means if I highlight it, that, make that a little darker. that this one is the same. So that is also 2.9. So if I have a circle, do I have just a plain circle somewhere? So that is 2.9 for the diameter of my circle. Since I'm imagining that this circle keeps going around. And that means that if I just want the radius of the circle, it's going to be half as much. Does that help?
Yeah, but so that would be the measurement of the half circle?
That's the radius. Then we said that the area of the whole circle would be pi times r times r. So we plug that in. And then we have it divided by 2 because we don't have the whole circle. We just have this half of it.
Okay.
So that's where that red divided by 2 comes in, because we're only having half of the circle stuck on.
Okay.
Okay. So I mentioned very briefly, but I wanted to put it in the recording, that we have a new playground. If you go to the playgrounds at the top, then there's one that we can play with next week of Sonar and Spies. It is like the game Battleship, but using our polygons, and it goes quicker, and I think will be more fun than Battleship. You don't actually have to sink all their ships. You just have to find out which of their polygons are in which corners of the map. So if you want, you could introduce us to that as a sharing thing next week. And if no one else does, then I will. But now we get to celebrate and move on to justice, things about solving an equation, doing the same thing to both sides of an equation.
Are we not doing presentations today?
We will. I was going to kind of wait till I run out of steam, but we can do that now if you want.
I was just wondering because the first problem on that one is what I'm doing, so I didn't
Yes,
know.
it is. So when I will get to that, and then you'll take over.
Okay.
So, but at first I wanted to sort of read this to you a little bit. So we have done a lot. If you noticed, then the first topic of mad science, first topic of shapeshifting, we did in 2 weeks. We needed to go slow and careful to review all that stuff about changing one number into another, but there wasn't a whole lot of stuff there. It only took us 2 weeks to finish it. And the shape shifting, it took us a while, all of weeks 3 and 4 and 5 and 6, and then just a tiny bit now at the end of week 6. So justice is now the last one, and it will go faster. I don't know if we'll be done in week 7 and 8. If it takes longer, that's fine. But we have so much stuff behind us now. Our foundation has gotten strong that this will go fairly quickly. Then we'll do other things to reinforce what we've done, go a little more deeply, and things that are more fun and less about just, here's a skill, practice it. So we're calling it justice because we're doing the same thing to both sides of an equation. If two things are equal, if they're going to stay equal, we have to change them in the same ways. If I'm making a recipe, I have to double how much flour and how much milk I use. If I just change one side of something, then it doesn't stay balanced anymore. So this is one of our two big tools in our toolbox, because we can't just change numbers however we want. We've done a few types of tools already. So we have a tool where we said this fraction, we can't just change 2 and 3 however we want, but if we do something to one top or bottom, we can do the same thing to the top, and that doesn't actually change our number. Or we could reduce a fraction instead of unreducing. We've also seen how if I have something like 5 inches, then I could put that over 1 and multiply by 1 foot is 12 inches. And that worked because 1 foot and 12 inches are two names for the same thing. And a fraction whose top and bottom are equally big, that's just 1 written in a complicated way because the top and bottom are the same size, just like the fraction, 4/4 or something like that. So we've had a few ways to change things without really changing them. And this is exactly the same kind of stuff. So the first thing we're going to look at are one-step equations. We can think of them like a puzzle. And at this point, I will stop talking because Sukoya wanted to do this one. Okay, your turn, Sequoia. I will be your hands.
Okay, so we're solving for y, so you would divide by 5 to both sides to get the
Let
y
me
by
write it
7.
big because sometimes it's hard to read on the screen. Y times 5 equals 35. And you said divided by 5 on both sides. Tell me how to write that.
I just put make it like a fraction, put a line and then 5 underneath,
Like that?
under just the 5,
Under just the 5. Okay.
and then under the 35,
Okay.
which gave me y equals 35 divided by 5 is 7, so y equals 7.
Okay. Can you check your work?
I did, yes.
And how do you do that?
I went to see if the answer was right on the website.
Ah, okay. Yes, if you have the answer key, you can go ta-da and see. I was thinking you can take the 7 and plug it in to the y. And 7 times 5, is that the same as 35? Yes, it is. Okay. Thank you. Yay. Cheer for Sequoia. Anyone have questions about what she instructed?
I'm good.
I don't want to talk more about why that worked. First, I want to point out that the order of the things doesn't matter. if I have multiplied by 5 stuck onto y, it doesn't matter what order I write these. I could rewrite it like this one without any trouble and switch which comes first, the y or the 5. So it makes sense that in this case, I could also say divided by 5 on both sides and get y equals 7. Let's do another one. So 4 times b equals 20. How would we get b by itself? What's the opposite of a times 4 stuck on something?
Divide 4.
Divided by 4. I'm going to write this differently as just divided by 4 like that for variety's sake. It's not that one is right or wrong, although I will talk more about this in a moment. So b times 4 divided by 4. A times 4 and divided by 4 cancel out, and I get b by itself. And then 20 divided by 4 would be
5.
5. So why is that working? Let's look at this picture. So this picture is saying 4 B's, right? 1, 2, 3, 4 of them. They weigh as much, they make the scale balance, they are equal to 20. So is everyone okay that my balance scale looks like this line right now?
Yeah.
So what happens about the divided by 4 or an answer of 5? What's happening there?
Dividing by 4 on both sides, so it's still balanced.
Okay, tell me how to draw that.
I'm
How
not
do I
sure.
draw dividing by 4 on the left side?
I'm not sure.
Whatever we do, we will get to 1B. So
Would you just write it under it or?
I think what I would do is just cross out 3 of them. Imagine that I pick up these 4 things that are labeled B, and I give one of them to each of 4 different people, right? Dividing by 4 is like passing out cards. And each person gets 1. So there is one person's share of that. Or we talked about how division could be like making piles of the same size. So I pick up all 4 of these and I make piles of size 4. And how many piles would I get? I'd get B different piles, but that doesn't really work with this picture. So better to think of I'm dealing these out to 4 different friends and each friend gets 1. And then one of my friend comes back and puts his or hers on the balance scale. How about the other side? How do I do divided by 4 with a 20? How do I pass it out to my 4 friends?
You split it up.
I have no idea.
Yes, maybe talk to each other. How could we do 20 divided by 4? We have the 20. I want to do divided by 4.
Cut it in 4 pieces.
Cut it in 4 pieces? Sure. So each of those matches up with one of the B's. 3 of them we give away. And then one of them, the friend who gets this piece and this piece decided to come back to the empty balance scale and put them back on. And hey, they match. And he says, how much is that piece? That's 5. That's 5, 10, 15, 20. Does it make sense now, the bottom picture that you see it?
Yes.
So like most of my pictures, you don't ever have to draw this. No one on any test will ever say, fill in the balance scale to make 4 times B equals 20 look nice. But hopefully it helps at least some of people understand what's happening. That it's not just a magic rule. It's, do the same thing to both sides. We should be able to draw a picture if it's actually something that makes sense. Okay, continuing. Here we have another one. This one is a little harder because division is harder to think about, but you've just had some practice. So let's try it. So P divided by 6 equals 8. What's the opposite of divided by 6?
Times 6.
Times 6. So if I divide by 6 and times 6, those cancel out and P is by itself. 6 times 8 is 48, and I get an answer. Questions about the writing it out in algebra side?
No.
I'm good.
Okay, let's see if we can make the picture make sense. Okay, so we had a whole pizza named P. I guess B was for what? Block? Who knows? Anyway, pizza is for P. And we divided it by 6. So I get 1 slice of pizza. 5 other people took their piece away. And that piece of pizza was equal to 8. So where is the times 6 when I move from one picture to another? What should I draw?
Would you cut each half of the peas in half? Does that make sense? Like do,
P is the whole pizza. I could cut it in half, but it's already cut into 6, and 5 of them were taken out and eaten. The only thing I have left to work with is my slice. So what would my slice times 6 be?
is it 6?
I could put one more copy of my slice. That would be my slice times 2. If I did another one, that's my slice times 3. If I did another one, that's my slice times 4, times 5, times 6. So this times 6 is saying, find the magic pizza photocopier and take your piece and make 6 copies of it. Get your whole pizza back. We're back to P. We're back to the whole pizza. How about the other side? What's that times 6?
I'm quiet. This is baffling me just a little bit. So
That's
I'm just
okay.
trying to take it in.
The pictures aren't always immediately helpful. Can I do a photocopy 6 times again?
Yes.
Yeah. So I will get this filled in just the same way. And how big is it going to be on this side? If each of those is 8, then the whole thing is going to be 48.
6.
So 8 and another 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 8, right? 6 8s makes 48. So I went from a pizza chopped into 6 pieces, of which only one is left, p divided by 6. That's the same as 8. And then for both of them, I made 6 copies of that. I filled in the circle. And I got that the whole pizza is 48. So if this helps you, great. If not, don't struggle with it. The whole purpose is to understand that if I'm doing times 6 to both sides, then there should be some clever way to actually think about what the times 6 is in a picture. I'm making 6 copies of something. I'm making 6 copies of something. Okay, let's stop staring at the pictures. Not everyone likes them. So I want to do this one. And do I have a nice fraction one? Yes. And I want to do that one twice. Okay, so if you are doing this, let me talk some about how to write it. Y times 9 equals 189. We've seen 2 things to do. We could either put like a fraction bar, because 9 over 9 is 1, and y times 1 is just y. That's a fine way to write it. What is 189 divided by 9? That'll be 2 is for the 18, and then 1 more, so 21. When I write this, I want my equal signs to line up straight. I want my letters to line up straight. Make it easy on myself so that later on, when I go to study for a final, everything is clear. You might not have extra colors, but this is a good place to use them if you have them. We have some rows that are equalities. They are saying things are true. And we have other rows that is what we're doing, how we change them. And as we go through our steps, we go alternating back and forth. Here's something that's true. Whatever number this is, if I multiply it by 9, I get to 189. Now we're changing things. We're describing how we're changing them. And now I have something else that's true. I have a number that's equal to 21. And these again are convenient because you can take 21, plug it back in and check if you get the right answer. So it's good for your brain to emphasize how we have different things happening. We have a statement of something that's true. It's almost like a noun, a thing. And then we have a how we're changing things. This is like the verb, what we're doing. Then to get a little bit more fiddly, when I have a fraction, the process doesn't change at all. I can say I'm going to divide by 8 on both sides. So y times 8 divided by 8 is just y. What's 2/3 divided by 8? I think I should do that kind of off on the side. 2/3 divided by 8. That would be 2/3 divided by 8/1. That would be 2/3 times, and we flip the second thing, 1/8. Let's do some canceling. And I get 1/12. So all of that is sort of my thinking off on the side. And I'll put my answer there. So as I'm writing them, my equal signs line up, my y's line up. It's easy to see which are my true statements of equalities and which is the verbs, the things I'm doing to both sides. And I don't try and squeeze all this blue and green stuff right in here. It's not going to fit. It would disrupt my flow. It would make it hard for me to go back and study with this. Everyone okay with what I've written on the right-hand side?
Yeah.
So I'm sure you can do great on GEDs and other tests if you write it other ways, but I encourage you, especially if you don't have any habits yet of how to write this, to be as organized as possible. It'll just make it easier for you later on. Okay, on this side, what happens if I write my divided by 8 with the fraction bar notation? This sure looks like y times 1, because 8/8 is 1. This side looks a little funky. I sort of have this tower of numbers. It's not quite as clear what's happening. Maybe what I should do is make this a big fraction bar instead of one the same size as the other one, or something like that. In any case, I'm going to write this 2/3 divided by 8, right? So it's going to have the same blue stuff going on. Oops. Blue, I can pick my color. It's going to be 1/12 again. But you will notice that I tend to not use the fraction bar way of writing things. I will use the division symbol. And this is why, because when you have fractions in there, it just tends to make it look like a tall totem pole of numbers stacked on top of each other. That's not quite as clear what's happening. But it's not wrong. If you like this style of writing it, keep doing it. Okay, questions about anything we've done so far with one-step equations?
I think I got it. Thank you.
So
Good.
there's some things about bad grammar here that I put here because every now and then I will see it, but I'm not going to talk about this in lecture because at this point, assuming that you have good habits of how to write it, either this style or this style, I'm not going to spend class time showing you the wrong way to write it and get that in your brain. That would be a waste. Okay, we can add and subtract also. Let's do one of each just to be complete. And then if we're getting bored with this, Is Emily ready to do her heart rate sharing?
Yes.
Okay, so someone who is not Sequoia or Emily, who didn't prepare a thing to share today, tell me what to do with either 7 or 8.
I'll do 7.
Okay,
Do you subtract 9 on each side?
you do. The opposite of add 9 is subtract 9. So those
And then
two
you
will
would-
cancel out.
Here's another background.
Shh, be quiet. And then you would get 191. U equals 191.
Ta-da, that's all. Don't make them harder than they are. How about on number 8?
I'll do it if no one else wants to.
Okay, I guess it's yours, Brandy.
Do you just add 12?
Yep, the
On each
opposite of
side.
minus 12 is plus 12.
And then it would be y or x equals 87.
Mm-hmm. Ta-da. And the last thing, do some more example problems if you want, is that there are 2-step equations. And I would urge you to look at this a little bit at home, but I'm not going to talk about it now. It would be too much all at once. And it's basically saying that if you have multiplying, it doesn't matter whether it's y times 3 or 3 times y. But if you have division, it does, because y divided by 3 is not the same as 3 divided by y. So we look at one of them and then say, how do we do that? And subtraction is similar. If I am adding, it doesn't matter. But if I'm subtracting, a y minus 7 is different than a 7 minus y. So 27 through 32, we can do next time, see if we got this or not. And I'm not really interested if you can do the 2-step ones. That's harder than level C is supposed to be. But I want you to be wary, to have your danger antenna up, just to know that whether the letter or the number on the side that has both, which one comes first matters for subtraction and division, but not for addition or multiplication. The next topic we'll get to, which I'm happy to start today after Emily goes, is cross multiplying with proportions, which people tend to love. One of the reasons that we save it for close to the end of the term is otherwise people would have been cross multiplying like crazy earlier when you're not supposed to. So by not talking about it till now, then for things like reducing and unreducing fractions, no one has tried to cross multiply. So yay. But this is something that people like doing, but we're not there. Okay. So Emily wanted to talk about heart rate formulas. Tell me what to put on the board.
So you put the formula on the board.
Okay. And tell us about what are these things?
So the maximum safe heart rate, how to find that, you would do 211 minus 0.64 and multiply by your age.
Okay.
And that's like the way that you find your max heart rate, I guess, like the guideline.
Maximum meaning if my heart rate gets this high, I should calm down and not exercise like this anymore, or I might hurt myself.
Yes.
Okay, what age are we using in our example problem?
35 years old.
35 years, okay. So I take the formula where we had age, I plugged in something. Now tell me what else to write.
So, would you want to solve that first, or should? I wasn't sure how this would go completely, but
Well, you sent me a picture of your work, so I know you've done this correctly.
oh yeah.
I
So
put it,
you would do 0.64. Yes.
so 211 minus 0.64 times 35. Do I need these parentheses?
No.
No, it's going to multiply first anyway, right? Multiplying has higher priority than subtraction. These are two
Yeah.
different terms. So the parentheses are put in this formula just to help your eyes identify the term, but we don't actually need them here. So it's about 189. And these are beats per minute. Okay, that's the first one. So the lower limit,
So to find the lower limit, you would do the maximum safe heart rate, which is 189, and multiply it by 0.5 or 0.5.
so previous answer times 0.5, I get about 94. And then the upper limit,
You would do the max and multiply it by 0.85.
so instead of 0.5, make it 0.85, and I get about 160. And what do they mean by lower limit and upper limit?
I think like the lowest it can get during that exercise, and then the highest it can get.
Yeah. So for aerobic exercise, it's not just like a description. When I go jogging, it's aerobic, but it really means something. Your body is burning a different ratio of fats and carbs when you're doing aerobic exercise. And to get your body in that different metabolic state, then you have to have a heart rate of at least a certain amount. And you probably don't want to get closer than 85% of your max. If your workout is so intense you're at 160, that's a good place to stop. Don't try and push it harder, or you might accidentally hurt yourself. Okay, yay, cheers for Emily. Any questions about her presentation?
I'm good.
I'm good.
So if you look at the
Yeah.
syllabus, they have the course description, and there's these state standards for what you're supposed to be learning, right? I'm sure none of you have looked at this. It's kind of boring. But one of the things it talks about is being able to communicate math orally. So practicing talking about it is good. Then if Emily or Sequoia wants to get a letter of recommendation for a job someday, I can say yes, they can even make presentations in front of their peers talking about math things. So it helps you understand the math better. It's more entertaining to the rest of the class than me talking, and you can talk about math. So, Okay, we're at a transition spot. We're going to talk next about proportions and cross multiplying. Do you want to take a break now, or should we push on closer to 8?
I'm good to wait.
We can wait.
Wait, okay, let's keep going. So proportions and cross multiplying, which people love. And as always, my job is to assume that maybe you've seen this, maybe not, but either way, maybe you haven't had it explained carefully, so I will try and explain it more carefully than you would have seen. Okay, a proportion is an equation of the format ratio equals ratio. And rates are just ratios with labels, so that works too. So I could say 30 miles per 1 hour is the same as 60 miles in 2 hours. Or I could say that the medicine has 2 micrograms of active ingredient per 10 milligrams of medicine. And that would be the same as 1 microgram of active ingredient if you only measured out 5 milligrams of the medicine, or something like that. So we have a ratio or a rate equals another ratio or a rate. If we had anything else, it's not a proportion. So if we do something like 2/3 is x plus 3 over 5, and there's something else happening in the top, we're not going to talk about those. Or if we had something like 2/3 is 1/8 plus y, then there's something else happening on the side. That's not a proportion. So just that simple, right? A rate or ratio equals a rate or a ratio. And on this screen, let me make it a little bigger. There's this thing called cross multiplying. And we can use it to check if proportions are true. It's kind of weird. So somebody thinks that, is it true that 2/4 is the same as 5/10? If I do that, if I want to check that, let's multiply in an X shape. 2 times 10 and 5 times 4. So 2 times 10 from the gray diagonal, 5 times 4 from the blue diagonal. Is it true that 2 times 10 and 5 times 4 are the same? Yes, they're both 20. Therefore, this was true also. Or for one that doesn't work, is 6/7, is that the same as 8/9? Let's check. We'll do multiply diagonals. 6 times 9 from the gray diagonal, 8 times 7 from the blue diagonal. Those don't match. 6 times 9 is 54. 8 times 7 is 56. So those are not equal. So this is not true to start with. I suppose there should be, and whoever made this, it wasn't me originally, a question mark there. We're saying, are those equal? Okay, is there anyone that's never seen cross multiplying before?
I've never seen that.
Never seen that. Okay, it seems like a nice trick. We don't like
Does.
fractions much. So taking something that has fractions and turning it into an equation that has no fractions, that seems pretty friendly. So for those of you who have seen it, why does it work? Why can I just multiply in an X shape? I only once have ever had someone answer this. So if you don't know it, that's fine. That's more a comment about your old math teachers than about you.
I'm not sure.
Maybe Ruthie can help since she's never seen this before. If somebody asked you before today, can you compare 2/4 and 5/10? What would your instinct be to do?
Would it be cross multiply, something like that?
No,
Multiply.
you said you've never heard of cross multiply before. So
Oh, no, yeah, no.
how would you know if these are the same amount, 2/4 of a cake and 5/10 of a cake?
Because they're both 5 is half of 10 and 2 is half of 4.
Yeah, you're on the right track. If I wanted to be really lazy, I could say, let's find common denominators. And if I'm smart, I could notice 20 doesn't work, but let's be not smart. We can always make a common denominator brute force by multiplying each denominator by the other, right? So I'll take this 4 and do a times 10, and this 10 and do a times 4. Then they're both 40. I don't have to think at all. I just multiply each one by the other. Ready so far?
Yeah.
Okay, so I can't change only the bottom of a fraction. What's my next step going to be?
You got to multiply the 2 by 10
Mm-hmm.
and a
And the
5
5 by 4. And then I would get 20/40ths. And is that the same as 20/40ths? And I'd say, yes, those are the same. Everyone okay with what we did here on the right?
Yeah. Yeah.
Okay, now compare it to the left. This 2 times 10 is this 2 times 10. This 5 times 4 is that 5 times 4. And these 20s are these 20s. Cross multiplying is finding common denominators by multiplying each denominator by the other one. But because we know they will match, of course they match. That's the whole reason we're doing this, is each denominator times the other one is going to be the same thing, right? 4 times 10, 10 times 4. We don't need to write the denominators. All we have to do is write the numerators. I could put over 40 over 40, but that's a waste of pencil lead. That's a waste of ink. No one cares. Of course the denominator is going to match. So the only thing I have to check is if the numerators match. So you don't have to remember that. Like everything else with pictures, you are smart enough to understand it. It's not some magic process, but you deserve to know why it works. It's bad math teaching if people just say, here is something and never explain it to you. So that's all it is. It's nothing new. It's nothing fancy. You know how to find common denominators. We're just writing less because we're lazy. Okay, let's do some examples. Number 30 needs editing there. It has No problem number. On all of these, the website unfortunately writes its fractions with diagonal kind of slanty stuff happening. And it's really hard to make my cross multiplying diagonals when my fractions are not having nice straight up and down posture. So I encourage you, always rewrite them the nice way, straight up and down. Don't have this kind of diagonal business going on. I wish that the website could do better, but it doesn't. So is 4/9 the same as 12/28? I take a diagonal, 4 times 28. And I'm wondering, is that the same as the other diagonal, 9 times 12? So what's 4 times 28? 112. 9 times 12 would be 90 and 18. So
108.
that's not going to work. No, they're not equal. Can we do another one?
Yeah.
Okay, this one looks scary because it has decimals in it, but that's okay. We have calculators. The decimals don't make this any harder at all. So rewrite it up and down with good fraction posture, because otherwise I can't do my little diagonals very well. Okay, so one diagonal is 1.2. Okay, I'm gonna write this very carefully. 1.2 times 7.56. This is a great time to confuse yourself by making your decimal points that are decimal points look the same as your dots that are multiplying. If you are someone that uses X's for multiply, you're on safe ground. But if you're like me and have the habit of dots, then you have to really write carefully here, or you're just going to make a bunch of mess. I try and make my multiply dots a little higher and a little bigger. So 12 times 7.56 is 90.72. $1.8 times whatever that was, 4.99 is, oh, it was 1.2, so that's going to be smaller. 9.072. And then the other one was 8.982. And those are not the same. So again, our answer is no, the original things were not equal. Everyone ready to do these on homework?
Yeah.
So multiply one diagonal, multiply the other, and compare them. You have a calculator, multiplying is the calculator's job. This isn't too bad. Where it gets interesting is when you have variables. So far we have been checking. We're getting yes or no answers. Is it true that something equals something else? Now we're going to play a very different game with exactly the same procedure. So this one is kind of different philosophically. I'm not putting a question mark over my equal sign anymore. I'm saying there must be something that I can plug into y, just like earlier in class. We could plug something into age, or plug a 12th into y to check it, or plug 191 into u to check it, right? Plugging things in is a common theme. There's something that I can plug into y to make this true. I'm not wondering if it's true. I'm going to force it to be true. So what works for that? That's my different question. But the process is exactly the same, because finding common denominators is still the right thing to do. And I don't want to write the denominators. Of course, they will match. So I will just write the numerators and be lazy. So 32 times 3, that'll be 96. Now I have the one-step equation, like Sequoia introduced. Y times something equals something else. So how do I get that y by itself?
Divide by 8.
Divide by 8. Opposite of times 8 is divided by 8. I had asked you earlier to keep a heads up that division in this line might trip you up, but it will never happen. Since our cross multiplying is always multiplying, these are always nice and simple. They will never trip you up. So 96 divided by 8, and I get 12. And I could plug it in, put a 12 there and check and see if it works, and it would. Okay, questions about this example problem before I talk more?
I'm good.
No.
Oh, thank you.
Okay, this one is no harder. Again, we have calculators. The decimals don't make it any harder. But I'm going to talk a lot more. So if I multiply two things, the order doesn't matter. Right? If I have, let me go back to the beginning actually. A big theme from today was that multiplying two things the order does not matter. Whether they're both numbers we know, 2 times 3 equals 3 times 2. Whether one of them is a letter, y times 5 equals 5 times y. It's okay to flip the order. And one way we thought about that was making rectangles. It doesn't matter if we turn our rectangle in space a little bit. It's still the same size when we shade it in. If I have a rectangle and I have y and 5, and you draw a rectangle that's 5 and y, then they have the same area. That makes sense to everybody?
Yeah.
Okay, so going back to where we left off, I have an equal sign. Does it matter which diagonal I put on the left or right side of the equal sign?
No, it doesn't matter.
No, right? If this equals that, it doesn't matter which one I say first, they're equal. So I'm always going to pick the diagonal that has my letter to put on this side. That's just a habit I have. It makes the problems all work the same. When I am multiplying y and 1.2, doesn't matter which one I write first in the multiplying.
No?
No, we just talked about that. So I am always going to make two choices when I do these. I'm going to pick the diagonal that has the letter and put that on the left side. And I'm going to pick the letter to go very first. I can always do that. Have my letter times something equals something else. And that way, these always turn into the very friendly 1.3 times 96 is 124.8. Because these are the type of one-step equations that make my brain the happiest. A letter times a something equals something else, right? So I can force it to look like that. Pick the diagonal with the y first, or whatever the letter is, and put the letter first. Okay, finish up times 1.2. It's always going to be divided by the thing stuck onto your letter. You never have to worry, do I divide, do I multiply? You're always dividing. $104. Okay, questions about this board?
I'm good.
I'm good.
We are at 20 out of 20, so to keep going, I need to make a copy of this. Then we can clear it off and keep going. Oops. Close that. Okay. So that's what this is saying here. We can always put the diagonal with the variable to the left, and we can always put the variable first if we want. Okay, there's a little bit thing here about good habits. I'm not worried about that. If you were going into Math 60 soon, then we should worry about some habits, but let's not worry about that. We could talk about word problems, but let's look at some random ones. Okay, so the first one, which I will write bigger so you can read it, check if this is true. 6 to 16. Is that maybe proportional, which just means equal, to 36 to 96? Does someone want to lead me through this?
I can try.
Sure.
Excuse the kids in the back. So does it matter how we start the cross multiplication?
No, we already just said it doesn't matter which goes on the left or which goes on the right. So
So it would be 6 times 96.
sure. Whoops. I have to actually make my chart nice. Okay.
And then 16 times 36.
Okay. 6 times 96. It's 576. And is that the same as 16 times 36? It is.
Yes.
Nice to have one of these work out. Okay, yes. Okay, somebody else, one with a letter in it this time. 18 over 7 is going to be, no choice about it. We will force it to happen. N over 12.
So we can do the n times 7.
Yep.
And then 18 times 12.
Oops, that's kidding. So n times 7 just hangs out for a little bit. 18
Then-
times 12 is 216.
Would you divide both by 7?
Would. That gets the n by itself and says the answer is 216. Answer divided by 7, about 31. These aren't word problems, so I'm not sure how much to round, if any. I'll just round a bit. Remember, our general rule is use the same number of decimal points as you had in your problem, in this case, none, or put one more decimal point on if you want. Okay, again, keep your equal signs lined up. Keep your letters lined up. Make it clear which are the things, the nouns, the true statements, and which are the verbs, the stuff you're doing. And keep it organized, and that way, when there's time to study for the final, it will all make lots of sense to you. Okay. A lot of these involve word problems we haven't gotten to yet. You want to keep going and move on to the word problems, or the other thing we could do that would make sense is to go back to the mad science test and see just if we really feel like we finished with this or not.
I would like to do
Math.
a test.
Go over the
Good
test.
Go over the test.
Yeah.
Okay,
Yeah.
so don't start these 10 exercises yet. There's too many word problem things. We're not there yet. But having all of this cross multiplying in our brain is nice. And as you saw, we have lots of example problems we skipped over. So spend some time before Tuesday. Try these. They all have answers. See if you really understand it well. Okay, just as a side note, the homework, as you may have noticed with annoying problems like Grandma Jorgensen, is always harder than the test ones. Your final exam is going to look like the tests, not the homework. Since we have time in class to talk about the homeworks, that's the appropriate time for me to really challenge your brain. Let the people that sort of want to do A-level work show off that they get it. I'm not going to have you do something that hard on a timed test, even if they're not timed because it's remote. So these ones shouldn't be as hard as the hardest homework. So I'll make it a little bigger. We have, I should mention for the sake of the recording, at the bottom of the shape-shifting table of contents, there's a test. That should be old hat stuff by now. And at the bottom of the mad science table of contents, there's a test. In our new topic of justice, there's two. There's one gist for justice, and then there's one labeled the Math 20 overview, which is all of this. I should rename that so it doesn't say 20, because level C is pretty much the same stuff. But we're not there yet, of course. Okay, so are we really done with mad science? Any of these things you want me to do or you want to work on together, we can.
I'm still trying to do the last exercises for the math science.
Okay,
So if you're
did you have one you wanted me to work on before we do this? If not, then just turn them in on Tuesday. Do what you can.
Yeah, I think I'm good. I'll let you know though.
Okay. Yeah, send me emails if you get stuck.
Can we do number 3?
3, sure. This one is just a lot of words. It's actually not that bad once we figure out what's happening. So a mad scientist has 12 vials of liquid something. So I'm going to draw 12 little vials. 1, 2, 3, 4, 5, 6, 7, 8. These really don't look like test tubes, do they? They kind of look like Playmobil people. Anyway, each one has 17 milliliters. So how much do I have all together here?
Is it 17 times 12?
Yeah. 17 milliliters in each one times 12 of them. $204. Okay, so far we're up to 204 milliliters. And then to that, we're adding my bigger container, 134 milliliters of water. So that means 204 plus 134 is 338 milliliters total. So that's part A. Then he sets out a new kind of beaker that's 19 1/5. So there's one of them, there's another, I'm not sure how many there are, right? And each one is 19 1/5. I don't really want to have a fraction there. So let's change that. How do I make 19 1/5 into a decimal?
Do you do 19 times 5 plus 1 over 5?
That makes it an improper fraction. That's even more fractiony.
Would you do 1 divided by 5?
Yeah, so I do the 1 divided by 5 and I get 0.2. And so 19 and the 1/5 just becomes a 0.2. The 19 kind of hangs out in front while I change my fraction into the decimal. Does that make sense?
Yeah.
So each of these is 19.2. And then the question that this awkwardly worded thing is trying to ask is how many of these red beakers can he fill up before he runs out of this stuff? Because if there's not enough for the final one, he just gets rid of it. So how would we find that out? How can we take this much and make piles of size 19.2?
Do you divide?
Yeah. So 338 divided by 19.2 is 17.6. Whoops, I need to actually write with a thing. And what happens with that 0.6-ish? That's the part of a beaker he just gets rid of, pours down the drain. So 17 beakers filled. He can't round up because he doesn't have enough actual mad science formula to fill the last one. Questions on number 3 now that you've seen it?
No, I think the
Um,
pictures helped a lot.
Yeah.
I don't like how this is worded here. I want to figure out how to reword that more clearly.
Yeah, it's kind of scary if it's long worded like that, but then when you break it down, it makes more sense.
Well, that's why you have the practice tests, because nothing will be a surprise on the thing. Okay, next one to do. Or we could take a 5 or 10 minute break. You could work on some yourself. And when we come back, know which ones to ask about.
Yeah, that sounds good.
So 5 minutes, 10 minutes.
Go with either or.
Okay, well, I'll come back in 5. If you're not back till 10, that's okay. So again, we're going to the mad science at the bottom, look at the test. Your problems won't match up with mine because every time it's random, but you can look at things and when we get back, ask a question or two. When we did the shape-shifting test like this, we actually spent a class day just going over this together. We certainly can for this one too, if you want, but your homeworks have been pretty good, so I'm not sure if we actually need a whole class day to review this or not. Okay, I'm gonna pause the recording for now and see you in 5. Number 13, after break on the mad science test. We're given a number and asked to find new amounts after an 11% increase. So we're going up by 11% and an 11% decrease. So we'll find some number and then go down by 11%. So whatever this number is to start with, let's just pretend it's $100. What do I multiply it by to get to something bigger? The 11% increase.
$11 over 100?
If I did that, that would just be the
0.11.
same as doing this rip-lop thing, going left out of percent. If I go 0.11, then the $100 is going to disappear. I'll get only the $11 of increase. So what was the trick that we used?
Does it show it or hide it? Is that what?
Yeah, we don't want to multiply by just 0.11 or this $100 will go away. I would just get 11 up here and that's not the right amount. So what did we multiply by to keep the 100 around?
One.
1, because times 1 doesn't change it. So that 1 is from the 1 plus trick. And the 0.11 is from the rip-lop of the 11%. Now, if I do 100 times 1.11, I get the 111 without the 100 vanishing. So that's one of our answers is 1.11. How about going down? This was a little trickier. Then I had my 111. And I want to multiply it again. This can turn into 0.11 because of left out of percent. And I could do things in 2 steps. Multiply it by 0.11. Now it's $12.21. So once I take away $12.21, what's left? $98.79. But that has 2 different steps, 1 step and 2 steps. And just like there was the 1 plus trick, so we didn't have to add the $100 back on, then we had the 1 minus trick. So I can take the 111 that we started with as we're going down this slide, and I'm going to multiply it by 1 minus 0.11. 1 minus 0.11, so 0.89. And that's going to get me my 98.79 all in 1 step. Except it's not really 1 step because I had to do this thing and this thing, right? So that's my other answer. So this problem is asking about oops, here. The 1 plus trick and the 1 minus trick. And if that's not your favorite thing, that's okay. There's nothing on the GRE that's going to look just like this, so. I'm sorry, GED. I'm saying my wrong G test.
Thank you for the refresher.
No problem. We've done a lot this term. There's a lot bouncing up in our heads. Another one. If we're getting all the way to 13 with only 2 questions, we're doing remarkably well. I would guess.
Number 11.
11. Okay, so they're starting at 166. And they're going down to 161. How much of a change is that, by the way?
5 pounds.
Yeah. So we have a formula that percent change is change divided by original. Does that ring a bell?
Yeah.
The change was 5. Remember, I write these diagonal because that always helps me know which one is the original, because I like to read it left to right. So about 0.03. I guess that's slightly rounded. Okay, I'm not quite done. What else do I need to do?
Change it from
Make it into a percentage.
Yeah, it asks what the percent is. So that's the right answer, but it's not in percent format. So
Right into percent.
there we go. Good job, random pretend dieter. You lost 3%. Questions on that one?
No.
We had a little bit more to this when it was new, wondering, are they showing the change? Are they hiding the change? But by now, I don't think you need that on the board each time. If it asks for change over original, change divided by original, and there's no change there, you can find it. You know you need to. Other things.
Number 15.
He drinks 19 cups of coffee per day. How many gallons per year? So this was the unit analysis. Do you want the list of the unit analysis steps on the board?
Sure.
Let's do that. So, so first we're going to move that. Write it as a fraction. So 19 cups every 1 day is poor body. That was rated as a fraction. Okay, what's my next thing to do?
Would you do 1 gallon or a gallon over cups?
Yeah, I want to get to gallons. That tells me gallons. So gallons, cups. If I don't know it, look it up. There's 16 cups in a gallon. Cups are going to cross out. So I'm halfway there. I don't have gallons per year. I have gallons per day. So I'll keep going.
Day over year.
Day over year. And how did she know to put day on top?
Cancels out the other one.
Cancels out the other one. Yep, that's my goal. Now I've done enough of these silly fractions. I have gallons and I have years, right? I can stop. I do need to put the numbers in. There's 365 days in a year. So these two steps kind of blur together. Then we multiply. On top, we have 19 times 1 times 365. I don't normally write the ones, but this time I am, just to be different. And gallons was the only word left. On the bottom, 1 times 16 times 1. And the only thing left on the bottom of words was years. So 19 times 365 is 6935. And then my last step was simplify. And just like we did with, here it is, taking a fraction and making it a decimal, top divided by bottom, same thing. Oh, except I need to write. So about 433.
Thank you.
You're welcome. Okay, it's 8:22. I think we should stop. I should help my kids get their dinner. So we have 2 jam boards for today. You'll get links to both in the after class email. Don't try and do the homework for 10 exercises of justice yet. We need to do the word problems. But if you haven't finished everything in mad science and shapeshifting earlier, you can. The measurement ones are kind of tricky. And if you want, try a test at the end of either the mad science or the shapeshifting. Make sure everything stays fresh in your brain. And again, those are a little easier, so that's nice. And if you want to present something on Tuesday, because that's fun, then tell me what you want to present. If you can show up at 6 on Monday, we'll do a little bit of extra study. Happy Mother's Day weekend as appropriate. Anything else before we're done?
Mommy, is the lettuce vegetable?
No, thank you. Have a good
I'm
night.
good, thanks.
It's been a while since we checked off achievements for anybody. So I don't want to do that tonight because it's already after time. But if you want to just meet me for a few minutes in Zoom between now and Tuesday, we can get you caught up on your achievements too. Okay, bye-bye.